It's very likely that at some time, everybody who has flown will have experienced turbulence, which at best means the aircraft has felt like it was riding a bumpy road, or at worst, has meant that all passengers and flight attendants have had to remain securely strapped into their seats, and the aircraft has felt like a ship at sea in a force 10 gale. Unstable air currents, or very high winds acting on the aircraft cause this kind of turbulence, and all pilots try to avoid it, not only because it causes discomfort to the passengers, but also because of the huge stresses it places on the structure of the aircraft. Prior to the Second World War, avoiding this type of weather was very much down to the skill of the pilot and his experience of reading the weather patterns, although many aircraft and their occupants were lost due to weather-related events. The EKCO company had been involved with the design and manufacture of airborne radar systems for military and civil use since 1939. After the Second World War, the company was contracted to determine if radar was capable of detecting cloud formations, with a view to developing weather radar for civilian aircraft, along with a collision avoidance system. Both Malmesbury and Southend factories were involved in the project. A prototype system made at Malmesbury was fitted into a short S.25 Hyde-class flying boat in 1947, and in association with the Telecommunications Research Establishment, extensive trials were carried out on Empire routes during the following year, to test its performance in bad weather. Continuous progress was made throughout the 1950s, with the E38 and E120 series, and in 1958, the E160 was produced for the de Havilland DH-106 Comet 4. It was essentially an upgrade of the E120. The unit was installed in the nose cone and provided search functions as well as ground and cloud mapping capabilities, with a radar interface built into the cockpit. Transistors changed the whole concept of circuit design. They operated at low voltages, and there was much less heat than the valve-based systems, and EKCO were quick to see the advantages. In 1959, development work started at Malmesbury on a groundbreaking transistorized weather radar system, the E190. Jack Halsall was appointed as project leader, and he was joined by Dennis Williams, Mike Skinner, and Mike Rose. Frank Burnell designed the transmit receiver, supported by Tim Gummer. The circuit design for the video signal processing was taken on by Mike Skinner, and Jim Cox designed the layout of the indicator, which remained virtually the same throughout its life. The scanner was a two-axis line-of-sight unit, with the need to withstand rigorous vibration and climatic testing. One of the big selling points of all the EKCO weather radar systems was their lightweight and compact dimensions, which allowed the inclusion of such features as twin indicators or duplicate systems, with minimum weight and space penalties. In fact, the E190 system when it was launched was the lightest weather radar system available. It operated to a flight ceiling of 20,000 feet, the magnetron transmitter radiated 9 kilowatts, and with its 180-mile range, it was a direct competitor to the RCA AVQ-50 weather radar on the General Dynamics Convair 240, 340, and 440 aircraft, and the Collins system, which was winning business on the Boeing 707 at the time. Another major improvement over the E120 and E160 was that it had a maximum range of 150 nautical miles, with selectable intermediate ranges of 20 and 50 nautical miles, with a 180-degree total scan in azimuth. A lightweight version of the E190 was also produced, which had its own servo system that enabled aircraft with a small nose radome to fit a small dish inside, although it had a limited sweep. British European Airways was the launch customer for the E190, and the system was subsequently retrofitted to many other BA aircraft. The British Overseas Airways Corporation, BOAC, specified the system for their order of Boeing 707-436 aircraft, and standardized the E190 across their entire fleet throughout the 1960s. By the end of 1961, the E190 system was selling worldwide. While piston-engined aircraft were being phased out, EKCO had to design a new modulator to power a 30 kW magnetron for jet aircraft, which operated at a ceiling of around 40,000 feet, and by 1963, the company had launched the E290, which enabled it to offer a range of weather radars to suit not only the world's leading airlines, but also the operators of feeder lines and executive aircraft. In 1965, EKCO won the contract to develop the weather radar for Concorde, and embarked on what was to prove their last major civil development, the E390 X-band system. But the unique operational requirement of Concorde presented new problems for the teams. One of the most notable challenges facing the design team was how to compensate electronically for the refraction angle that was caused whenever the droop snoot visor was operated. The challenge was met by a young graduate student who was on an EKCO sponsorship package with Cambridge University. He worked out the compound formula to calculate all the changes in the signal in longhand, filling a 6-foot by 4-foot blackboard. Concorde needed completely separate radar operating systems, and everything had to be duplicated. The complete E390 system consisted of several separate boxes that could be easily removed for servicing. The main boxes were the EKCO-built Type 3040 transmitter and Type 6 or Type 96 indicator units. 2 receivers were used. The first was the R3039 using VR95 Acorn valves, and the later R3084, using VR136 pentodes and VR137 triodes. EKCO and Pi built both versions. The conventional maximum range of 180 nautical miles was deemed inadequate for Concorde, given its achievable speed, so a special pencil beam with a 360 nautical mile range had to be developed. Weather radar is one of a large number of instruments in the aircraft cockpit, and it can only command a small portion of the pilot's attention. So while negotiating a storm front, it's not an issue because the radar becomes the primary navigational instrument and is continually monitored. But in phases of flight where the workload is high and weather problems are not anticipated at long range, the radar is often switched to a shorter range scale. It was in 1961 that Eric Cole announced his retirement from the company. EKCO had merged with Pi in 1960 to form a new holding company, British Electronic Industries Limited, with Charles or Stanley as chairman, and Eric Kirkham Cole as vice chairman. His view was that the entire EKCO middle management he worked with had survived from the 30s, when as a young team with the skills and enterprise of the time they had exploited the wireless boom. Quite exceptionally, after being absent or on other work in the war years, they were asked to do the same job again for television, a product immensely more complicated, when they were, in his view, too old, too tired and too out of date.